Everyone, I am Mohammad Wes from Jahangirabad Institute of Technology. I am a data science and business analytics intern at the Spark Foundation, and this is the second task of my data science and business analytics internship. In this task, we are going to predict the optimum number of clusters and represent it visually. The dataset is given iris dataset with the help of unsupervised machine learning. Now I am going to my GitHub repository. In this, the Spark Foundation internship is given all details here. Now, first of all, I want to know about task 1. From a given iris data set, predict the optimum number of clusters and represent it visually. So what is the data set? Iris data set. Iris is a family of flowers which contain three types of flowers called setosa, versicolor and virginica. Dataset is given on this link. Can download it by clicking on this link. And the problem, what is the problem? The problem is that we have given some features of flowers, and based on these features we have to identify which flower belong to which category. In this task we are going to use k-means clustering. So k-mean clustering in machine learning, there are three types of machine learning. One is supervised machine learning, second one is unsupervised machine learning, and the last is reinforcement machine learning. So now I'm going to explain the whole code. First we know about cluster. What is a cluster? So cluster is simply homogeneous groups, subgroups that are divide the data. And I'm trying to explain one of most popular unsupervised machine learning, which is k-means clustering, in simple way with some Python code. Here we will use simple implementation of k-means here to just illustrate some concept. Then we will use scalar implementation that is more efficient, take care of many things for us. First thing I am going to do is import libraries and dataset into pandas data frame. So you can see that I imported essential libraries in step 1, Python libraries that we are going to use in this code are pandas for data manipulation and numpy for numerical calculation and array. Matplotlib is used for plotting graphs. Sklearn is free machine learning library for Python. In feature various machine learning algorithms and functions. And then I have my data frame ready with that, and since the data set is simple enough, I will first try to find shape of the data set and print some rows by using head method. Then I will try to plot it on a scatter plot. These are the keys in the data sets. Now when I plot it on a scatter plot, I just want to plot the sepal length against the sepal widths. This is the sepal length and sepal widths. In the visualization part, Okay, when you plot this one scatter chart, you see three clusters, 1 and 2 and 3. Here you can see 1 clusters, 2 clusters and 3 clusters. So this particular case choosing k is pretty straightforward. So we'll use k-means. So k-means is something we imported here, and of course you need to specify your k, which is n clusters. So it creates this k-means object for you, and it has all these default parameter. I'm just trusting on the default parameter, and the second step is fit in predict. So in previous supervised machine learning algorithm, we used to do fit first and then calculate the score. But here I'm just directly doing fit in predict. I'm going to fit and predict the data frame excluding the petal length, petal width and species column, because species column is a string and it not gonna be useful in our numerical computation, so I want to ignore it. So you do fit and predict, and what you get back is y predicted. So now this statement did, it is run k-means algorithm on assign triple length and triple width and petal length and petal width, which is this scatter plot, and it computed the cluster as per our criteria, then identify their clusters somehow. And it did it, just assigned them different labels. So can see three clusters 0, 1 and 2. Now visualizing the array. Here cluster 1 is 0, cluster 2 is 1 and cluster 3 is 2. What we want to do is we want to plot it on a scatter plot so that we can see what kind of clustering result did it produce. So in my data frame I'm going to append this particular column cluster so that my data frame looks like this. So now this is little better. What we need to do, we need to separate these three clusters in different data frames. So let me do this. Iris data frame 1 is equal to cluster is 0. So what it's doing is it's running all the rows from data frame where cluster is equal to 0 and second cluster will be 1 and third cluster will be 2. So now we have different data frames each belonging to one clusters, and I want to plot these three data frames onto one scatter plot. See three different data frames, and we are plotting these data frames into different color. Okay, cluster 0 is green, cluster 0 is green, and cluster 1 is red, and cluster 2 is black. Let's see how that looks. Alright, I see scatter plot here, but there is little problem. So this red cluster looks okay, but there is a problem with these two clusters. You know, they are not grouped correctly. So this problem happened because our scaling is not right. when you don't scale your feature properly, you might get into this problem. That's why we need to done some pre-processing and use min-max scaler or to scale these two features, and then only we can run our algorithm. So we are going to use min-max scaler so that so the way you do it, you will say scalar is min-max scalar and this min-max scalar, and this is something if you already noticed we imported in the library section. So scalar is this a scalar dot fit iris data. So now I want to fit first the sepal width and sepal length. My scalar min max scales try to max try to max the scale 0 to 1. So after I am done with my scaling, I will have a scale of 0 to 1 y as well as at x axis. So iris dataset scalar dot transform. Okay, so now scalar will scale the sepal length and sepal width feature like this. Let's see how that did it. So you can see the sepal length and width is the scale right. It's like see 0.2 between 1 here, 0.2 between 1, this is 1, it lies between 0 to 1. So it is in the region of 1 to 0. You will not see any value outside 0 to 1 range. Now even if you plot these on the scatter plot, they will look structure wise, at least will look like this. So the next step is to use k-means algorithm against to train our scale data set. Let's see what scaling can give us, and as usual y predicted is equal to km dot fit and predict. So again I started with 3 cluster and I am using in just fit my data scale, sepal length and sepal width. Let's see my y predicted. So predicted some value which yet don't know how good they are, so I will just do cluster is equal to 3 predicted. This is my new clustering result. Let's plot this on a scatter plot. Now you can see I have a pretty good cluster. See black and red, they look very nicely. Here in the plot you can see the red black is looks nice. If you look at km, which is your train, and k means model that has variable called cluster, these clusters are basically your centroid. The centroid of the cluster is given here. This is the x-axis and this is the y-axis, and this point is for cluster 0, this point for cluster 1, and this for cluster 2. So first let's plot x-axis. I will use some special marker in color so you can see that these are the centers of my clusters. Here you can see a star which is the center point of the cluster. Now look into elbow plot method. In elbow plot method, let's define our k. Let's define our k range. Let's say I want to do 1 to 10 and then sum of square error is in an array, which is SSE. So for k is equal to 1, you will find SSE like this, and if you want k is equal to 2, then you will find SSE is equal to 6.85, and so on. So for k is equal to 1, you will find SSE this, and you will store all of that into this array and then use matplotlib to plot the result. Here in the elbow plot, you can see the elbow of the plot is at that point 3, and my cluster is equal to, I defined the cluster is equal to 3, that's why it represents the elbow at this point. Thank you if you are still here.